sample medians to make the jackknife work. So then some clever person said, by the way, this is the way statistical theory works. You see this as computation, but really there's a whole bunch of math behind it that's super cool that we don't talk about, but is back there. All computational methods, not always true, almost always there's a ton of math in the background. So we talk about it like it's an algorithm, and it is an algorithm. You just do it, and out comes an answer. But you can't just make stuff up and do it. There has to be a mathematical basis for why it's a good idea. Well, there doesn't have to be, because people make up all sorts of crap. But so clever person number 3, at least, said, let's do jackknife, but call it delete K. So instead of looking at only these n resampled values, let's delete more than one and say use all subsets of size, this would be size n minus 1, n minus k. There's a lot of subsets of size n minus k. And one of the papers that I wrote many years ago argued that k should be 25% of the data. And so I argued with Efren, who was my undergraduate advisor, that instead of doing, I lost, by the way, it's a long story, but it's not that long a story. I still got my paper published, and it's still, I still think I'm right. But so I argued that you should delete 25% of the data, because if you delete 25% of the data, you actually get exactly the same amount of variability that's over here. And it's better in some esoteric sense. Yeah. Let's see. Jackknife use all subsets advantage. By the way, the delete K jackknife is not my idea. It is it was developed to show that the bootstrap isn't the only way to do this. And there are other theoretical advantages that the jackknife has in some situations. So you will see sometimes things are jackknifed. Advantage works for the median. It's the fixed answer. Everybody gets the same answer. Computational nightmare. So the median is super easy to compute. We can do this 1,000 times. We can do it 1,000,000 times. It's fine. But if we're computing something that's messy, and usually you're bootstrapping or you're resampling in some kind of messy situation, then doing this is, because you got to do all of them, and all of them is too many. So in my 25% case, in the case of, if I was computational nightmare, 1,000, oh wait, how many data points do I have? I have 50 data points in my example. So this would be 50, choose 12, basically. Subsamples. I don't know how big 50 choose 12 is, but it's super duper duper big. And it's way more than the 1,000 over here. And it actually doesn't win in this case. It's just as good. Is a lot of subsamples. And actually I should do 52 is 12.5, but that doesn't make any mathematical sense. So my method of deleting 25% isn't even clear what it should actually be. Should you use a 12 there or a 13 there? I got to use something. So let's see. There are lots and lots of different versions of resampling methods. So there are lots of variations on the bootstrap. That, for example, regression has some special types of bootstrap. There are variations on the jackknife theme. There is, let's see, no statistical method is always appropriate. There's always cases where something goes wrong. In general, my percentile, if someone comes to me with some weird situation and I need a confidence interval, and we know that the theory hasn't been done, then we tend to use a bootstrap percentile confidence interval because it's easy to explain. Everyone understands it. It makes a confidence interval. Most investigators are happy with that. I have to explain to them that it's not symmetric. And they'll go, what? Why isn't it plus or minus something? Well, I said, well, look at the distribution of your data. It's skewed. It makes sense that your confidence interval isn't symmetric. But sometimes they don't like that, and then we have a tendency to go back to the second method here. In some cases, the jackknife is particularly advantageous, and so you will see jackknife confidence intervals and jackknife variance estimates as well. You're not going to probably be in a position to criticize someone for the type of resampling confidence interval that they used. You should know that if they mention the bootstrap, the jackknife, or resampling, that they're doing something like this. And in general, it's okay. But some of my colleagues, some of my social science colleagues, think you should bootstrap everything. And that's a terrible idea. They want to bootstrap the mean. That's the worst idea that's ever happened. Not quite. There are lots of bad ideas. But that one is particularly bad. Because there's no reason to bootstrap the mean when all the theory is done. You don't need to bootstrap them. Yes, of course you can bootstrap the mean, and you will get confidence intervals that work, that make sense. And they'll be close to the ones that the theories say are the correct confidence intervals. But there's no reason to make your life difficult and resample to get a confidence interval for the mean. So then they get into these complicated situations that social scientists deal with all the time, and they end up bootstrapping things, which is fine. What they don't understand is that their bootstrap fails. Just like all methods, there are assumptions. The assumption is, so if you want to see the bootstrap fail, the assumption is that we have a random sample from the population. In the beginning, this sample that we got is supposedly a random sample from a population. If that's not true, the bootstrap crashes and burns. because it's all based on the variability that's in the data. And so if there's dependency between the observations, and there's always dependency between the observations, then your confidence interval, your bootstrap confidence interval isn't right. So what do you do in that case? Well, it turns out you try to estimate how they depend on each other, and that changes the way you do this, which changes the way you do this, and you end up with a different bootstrap confidence interval for dependent data. And life is a lot easier when you don't use resampling. But there will always be situations where you can't do, the normal theory doesn't make any sense. And so you end up using resampling. The error that many people make is to assume that you can always bootstrap, and you can't. In most of the cases, bootstrapping works, but the reason that there are hundreds of different types of bootstrap is there are hundreds of situations where the bootstrap fails. It doesn't mean that the bootstrap isn't great. It is great. We can do it, and most of the time, it works great. But sometimes it gives stupid answers. You go, why did it give a stupid answer? Well, it gave a stupid answer for some reason that we may not understand. Maybe we need to do some more theory and figure out why the bootstrap fails in this case. And we can do that. That's what my students do. They work on things like this. They go, oh,